So last time we learned the vectors. And when we add the two vectors, say vector A plus vector B, we can switch these two vectors. So this addition is commutative. So we have the A plus B equal to B plus A. Okay? And similarly, when we do the dot multiplication for two vectors, and this dot production, okay, this dot multiplication is also commutative. So you can switch this B and A to get the same product. Okay, so the order does not matter. And some guy asked me, why two vectors, when two vectors are parallel, say vector A parallel vector B, the angle between them must be either 0 degree or the 180 degrees. Actually, if the A and B have the same direction, then you know, say this guy is the A, right? Let me use another color for B. So this guy is B. Then the angle between them is just 0 degree, right? So in this case, you have the theta equal to 0 degree. And if the A and B have the opposite directions, then, you know, A is like this. This is the A. And then B is like this. Now, in this case, you have the angle between A and B. This is just a straight angle. It's the 180 degrees, right? So, in this case, you have the theta equal to 180 degrees. And in both cases, you always have the cosine theta equal to either plus 1 or minus 1. Last time, we also learned the unit vectors, right? The two unit vectors. One is I. We have the I equal to 1, 0. This is the vector in the x-axis with the length 1. And then we have the unit vector j. This is 0, 1. And any vector in the component form, A1, A2, can be written as the linear combination of these two unit vectors. So that is A1 times 1, 0 plus A2 times 0, 1. So it's equal to A1 times j and plus A2, A1 times I and plus A2 times j. So now let's look at the one problem on page 612, problem 60. So in this problem 60, we need to write this vector as a linear combination of the unit vectors I and j. Okay, let's come back to the whiteboard. So it's the page 612, problem 60. We have the vector 1, 5. So actually, by this formula, you know, this is equal to 1 times I and plus 5 times j. And then you get the I plus 5 times g. Okay, very simple. Now let's look at another one. Look at the 62. So 62, we have the vector root of 2, negative root of 5. So we need to write this as the linear combination of this I and j. So actually, by this formula, you have the root of 2 times I and plus negative root of 5 times j. So this is equal to root of 2 times I minus root of 5 times j. Now let's look at the 74. Suppose we know vector A and vector B. Then we need to find the magnitude and the direction angle for this vector. Okay, 1/2 A minus 2B. So this is the page 612. Problem 74. We know the vector A 3, 1, vector B negative 2, 3. So right now we need to first find the magnitude of this vector 1/2 A minus 2B. So let's first compute this expression for this vector. So we have the 1/2 times 3, 1 minus 2 times negative 2, 3. Then we just multiply each component by this scalar. So we have the 3/2 and then 1/2. Right? Then for the second, you multiply this by negative 2, you have the 4, and then negative 2 times 3, you have the negative 6. Now you add these two vectors component by component. So 4 plus 3/2, you reduce them to the common denominator, that is 8/2 for 4, right? And then 1/2 minus 6. So this is equal to 1/2 minus 12/2. Then you simplify, you have the 11/2 and 1 minus 12, negative 11/2. So now we get the expression for this vector. Then the magnitude of this vector this is equal to the square root of the square of 11/2 plus the square of negative 11/2. And we know the square of this negative 11/2 is same as the square of the 11/2, right? So in this way, we have the 2 square of the 11/2. And you add this 2, you have the 2 times square of 11/2. Now you take this square out, then you have the 11/2 times root of 2. So now we find the magnitude of this vector.